Hi everyone. In this video I am going to provide a couple of illustrations of how to run a one-way ANOVA and ask for Tukey's post-hoc tests using SPSS. Basically post-hoc tests in general are utilized after the fact or after an ANOVA, or basically a statistically significant ANOVA, in order to identify possible mean differences among a set of groups. Basically, the one-way ANOVA serves as an omnibus test of group differences on a dependent variable, and doesn't really help you in terms of identifying where those group differences lie. And so post-hoc tests are utilized in order to explore possible mean differences. So in this video, I'm mainly going to focus on Tukey's post-hoc tests, basically because this is one of the more utilized post-hoc test options, and so at any rate, we're gonna move on to that. So to run the one-way ANOVA with Tukey's post-hoc test, there are actually two routes that you could do this through in SPSS. Route one is probably the simpler route, but you have really less opportunity for getting basically there's less information that you have available to you than route two. But at any rate, I'm going to show both routes. So we're going to start off with route one. We're going to go to analyze, compare means, and go down to one-way ANOVA. So when we click on that, this box opens up, and in our data set here, we've got our two variables. We've got an independent variable treatment, which is basically a categorical variable. We're going to treat it as a nominal variable. In fact, if you go under variable view, it's already set up as nominal. The second variable is anxiety, and that's a scale variable. It's basically falling in an interval scale of measurement. Scale would also apply if it was a ratio level variable. The main thing is that we're basically assuming that our dependent variable is continuous. So we're going to assume that we have basically three treatment groups. Let's say they represent three different types of counseling interventions, and we're looking at the effect of counseling intervention on anxiety levels after the treatment period. And so in this case, anxiety scores would reflect post-treatment levels of anxiety. So we began by moving the independent variable to factor. That's our independent variable here, and our dependent variable over to the dependent list. Under options, when we click on that, we can ask for descriptives. We can ask for homogeneity of variance tests. If we can ask for a means plot if we want. And if we wanted to ask for tests pertaining, under the assumption that there was a lack of homogeneity of variance, we could ask for Brown, Forsyth, and Welch tests. We're not going to really do that in this particular video, but those are available to you. So we'll click on continue. And next we'll click on post-hoc. And so when we click on post-hoc, this box opens up and we have Tukey's right here. Another option that one might adopt is utilizing sort of a Bonferroni approach, which basically takes a family-wise alpha level and divides it up into the number of tests so that you get a per contrast level of alpha for each test. So we're going to avoid that for right now. We're just going to mainly focus on Tukey's. You'll notice that these tests right here assume equal variances among your groups. These tests down here would assume unequal variances. But like I said, Tukey's is one of the most commonly utilized tests, so we're going to stick with that. Where it says significance level, it defaults at 0.05. And basically you could set this at a different level if you wanted to. The thing about it is that this really doesn't have much in the way of an impact on your results, because it really bears more on how the results are presented in a table in terms of what gets an asterisk and what does not. So we're going to click on continue and then on OK. And so in terms of our output file that you see right here, you'll notice that we have essentially a set of means and standard deviations associated with our groups. So basically those are, let's see, let me highlight this. These are the sample sizes right here. These are the means for your groups. These are the standard deviations and so forth. Here's the Levine's test, which is a test of homogeneity of variances. This is basically a p-value, and this p-value is compared against an alpha level. Typically it's 0.05, and so if p is less than 0.05, less than or equal to 0.05, conventionally that would signal that you've violated the homogeneity of variance with respect to the ANOVA, and then that actually impacts our confidence in our interpretation of the ANOVA results. If the p-value is greater than 0.05, as it is in this case, then we'll have greater confidence in terms of our ANOVA results. So at any rate, our ANOVA it basically involves an F test. This is the F value that's computed from our data. It's compared against a critical value in an F distribution. And this is a p-value, and this is basically the probability of committing a type 1 error if we were to reject the null. And so assuming that there's no difference among the groups. And so in this case, our p-value is less than a conventional alpha level threshold of 0.05. So what that would mean is that we would reject the null hypothesis and conclude that there's statistically significant variation in the group means. In other words, we would interpret these results to mean that we can infer that within the population there's significant variation in the means, or another way of putting it is that the groups are not all equal when it comes to anxiety scores or anxiety levels. So at any rate, we'll now scroll down to the main part here, which is post-hoc tests. So generally, like I said, you wouldn't want to interpret post-hoc tests like Tukey's if this is non-significant. There's not going to be a point because there will be nothing statistically significant down here. Nevertheless, in this case right here, when you're looking at this table of multiple comparisons, we're basically comparing group 1 versus group 2. So you've got I column and J column. So the mean difference is basically taking the mean for group 1 and subtracting the mean for group 2. So that's the I minus J that you see right here. So the difference that you observe right here is basically taking the mean for group 1 and subtracting the mean for group 2. And what this would tell us then, if you had a negative value, then that obviously is going to mean that the mean for group 1 is less than the mean for group 2. If this was a positive value, as you have right here, that would mean that the mean for group 1 would be greater than group 2. So you can see that group 1 has a lower mean than group 2. And this is our significance test. So this is testing whether the differences observed is significantly different from 0. So with Tukey's post-hoc tests, they basically are all adopting essentially a non-directional hypothesis, which is just testing whether there's a difference in means. It doesn't really address the question of direction of difference. We basically, these are p-values, and so we'll compare our p-values against our alpha level. And let's say we've set alpha at 0.05, then so if the p-value that's printed is less than 0.05 or less than or equal to 0.05, we would reject the null and conclude that the means for group 1 and 2 are significantly different. If the p-value is greater than 0.05, then we would essentially maintain the null and conclude that those groups do not differ significantly in anxiety within the population. So here we see our p-value right here is p-value is equal to 0.082, and that's certainly greater than 0.05. And so in that particular case, we would maintain the null and conclude that within the population, there's no difference between the two groups. So in this case, we would maintain the null and say no difference. When we compare group 1 versus group 3, the mean for 1 minus the mean for 3, you can see that the difference is negative 6.167. And so again, that would mean then that the mean for group 1 is lower than the mean for group 3 by about 6.17 points. And our p-value, though, is indicating that we do have statistically significant difference between those two groups. So in this case, our p-value is certainly less than 0.05, so we would reject the null. And kind of getting back to what I was saying before, when we this was the default in the little program in when we were in the menu option. And so the effect is that it just prints out a little asterisk right here next to what would be statistically significant. So there's a little asterisk right there indicating, again, that this is a statistically significant difference. You'll notice that we have a comparison between group 2 and group 1, and the mean difference is obviously in the opposite direction. The fact of the matter is that this is just a reversal of this, and so the results in terms of the p-value is going to be the same as what we had up here. So really it's pretty pointless to even bother looking at this because it's the same test as what we have up here. Nevertheless, we have group 2 versus group 3, which is the other pairwise comparison that's possible. So group 2 minus group 3 means, or the group 2 mean minus group 3 mean is negative 2.8, meaning that group 2, on average, folks in group 2 scored about 2.8 points lower than those in group 3. But here's our p-value, and you can see that it's not indicating a non-significant difference between those two groups. So the only group difference that's reflecting that is statistically significant is group 1 versus 3. You'll notice the confidence interval right here. You can utilize this if you want to ascertain significance. Basically, I generally don't. I just generally look at the p-values that are printed out. But if basically the confidence intervals are formed around differences, the computed difference in means, the mean differences that are presented right here. The null hypothesis is 0, meaning 0 difference in population means. So, if 0 falls between the lower and the upper bound, as it does in this case, that would indicate that there's no difference between groups. If 0 falls either on the upper or lower end of outside of the interval, then that would indicate that there's statistically significant difference in means. And so really the only one where that happens is this one right here, which we already knew when we looked at this particular area. So another possibility in terms of looking at or running Oneway ANOVA with Tukeys is kind of route 2, if you will. So if you go to general linear model, univariate, then basically this box will pop up, and we just move our independent variable to the fixed factors box, anxiety over to the dependent variable box. You can ask for all the usual suspects in terms of our options. We can ask for descriptives, effect size, power, homogeneity tests, and so forth. Click on continue. If we want to ask for plots, we can just click on plots, and it appears in this box right here. We can move the independent variable over here to horizontal axis, click on add, continue, and we've set that. Under Posthoc, click on that, and this box will show up, and we just move the independent variable over to the Posthoc test 4, and click on Tukeys. You'll notice that all the same Posthoc test options are available to you. Click on continue, and then on OK, and here's our output file. And so in this particular case right here, you can see you've got your group means right here. This is basically the grand mean. These are the standard deviations for the groups and also the n. So all that's the same as before. There's Levine's test, testing the homogeneity of variance assumption, as we talked about just a few minutes ago. When we scroll down, the tested between subjects effects, we're going to look at this line right here. This is the name of the independent variable that we were working with, which was treatment. So in a nutshell, we have our ANOVA summary presented. We have the F value that's computed from our data and the P value that associated with the test. So again, our P value is less than 0.05. Which is a conventional threshold for alpha. So again, we would conclude that there are significant mean differences on across groups on the dependent variable anxiety. The partial eta squared value is an effect size index. Basically within the social and behavioral sciences, 0.01 would be considered a small effect. 0.06 would be considered roughly a medium effect, and 0.14 or greater would be considered a large effect. That's using Cohen standards for the social behavioral sciences. So if you're in another field of study, keep in mind the conventions in that area. The observed power is just basically looking at the probability of correctly, rejecting a false null hypothesis. So at any rate, we'll move on and we'll scroll down a bit. You can see we've got the grand mean on anxiety. That's basically a cross group. The mean on anxiety across groups, observations across the groups, the means for the individual groups, and here's our post-hoc test again. So you can see we have basically all the information that I just went over above is present within this particular table right here. Our profile plot, that's just a plot of the means. That's just kind of provides a little visual there. So that pretty much concludes this review of Oneway ANOVA with Tukey's post-hoc tests.